Lesson 5.8, Coordinate Proofs. Essential question, how can you use a coordinate plane to write a proof? The basic tools are to show lines are parallel, show that they have the same slope. To show that lines are perpendicular, show that their slopes are opposite reciprocals. To show that segments bisect each other, show that they have the same midpoint. To show that their lengths are the same, show that the distances are equal. Let's take a look at a problem. We're given triangle JEN and we'd like to prove two things. We'd like to prove that it's isosceles. Isosceles has to do with showing two sides have the same length. When we want to do that, we use distance formula. To show something is a right triangle, we want to show that sides are perpendicular. To show that sides are perpendicular, we're going to work with slopes. Okay, the next problem has all the work. All right, notice that I have found the distance of all the sides. And I noticed that these two lengths are the same, so I write JE is equal to EN, and that shows that the triangle is isosceles. I have figured out all the slopes, and I label it so that I can keep track of my work. And I notice that two of the slopes are opposite reciprocals. So that means the lines are perpendicular. Perpendicular lines form a right angle, and so therefore the triangle is right. We now have another triangle and we want to show parallel, and we want to show that a distance is equal to a half of the other. We're talking about midpoints right here. We want to find the midpoint of AB, and the midpoint of AB will be P. And then we'd like to figure out the midpoint of BC, and that will be Q. Let's go ahead and do that on the next page. So I'm using my midpoint formula, and I find that P is equal to 0, 3, and that Q is equal to 3, negative 1. I go ahead and draw it on the diagram. So this is what I'm trying to prove. I'm trying to prove that PQ is parallel to AC. Proving something is parallel, you need to look at slopes. Now the next thing I'd like to prove is that PQ, distance PQ, is 1/2 AC. In order to prove that this situation is true, I need to look at distances. The next page will show you the work. Okay, you can see that I have found the slope of PQ and the slope of AC. Notice the labeling that occurs. When I find that the slopes are the same, I write down that these lines are parallel since the slopes are equal. Now I'd like to prove this portion as well, so I have to look at distances. Here's the distance of PQ, which is 5, and the distance AC, which is 10, and then I write down that PQ is definitely half of AC. This is the way I want to see you labeling your work. Okay, we want to find the area of this triangle. Now this triangle is not so easy to find the area of because the altitude and the base are hard to find. Let me show you a strategy in which we can use coordinate geometry to help us find this area. Let's take a look at the next page. What I've done is I've drawn a rectangle around the triangle, and the rectangle is red. Now I can figure out the area of the rectangle easily because I can see the base and I can see the height. And then I can find the area of all of these right triangles, and what I can do is I can take the area of the rectangle and subtract the areas of all these triangles. Let's go ahead and do the problem. All right, so you notice that the base is 11 and the height is 4. This is a 3 and then this is a 1. So the area of the whole rectangle is 44. Now let's figure out the area of this triangle right here, and that will be, and I'll keep this with red, 1/2 base times height, so that's going to be equal to 8. Now I'm going to find the area of this triangle, 1/2, the base is 7, and the height is 3, and so that's going to be 21/2 or 10.5. Now the area of this right triangle, the base is 11, the height is 1, so that's 1/2, 1 times 11, and that's going to be 11 halves, which is 5.5. Now I'm going to finish the problem. The area of the rectangle is 44. Take away 8, take away 10.5, take away 5.5, and that's going to be the same as 44, take away 8, minus, and if I put these two negatives together, that's going to be negative 16, which is the same thing as 44, take away 24, and the answer is 20. So we're able to find the area of an awkward triangle where we can't find the base and the height very easily. All right, let's take a look at proving that this SO bisects angle PRS. Now what we want to do first is we need to show the triangles are congruent. If we can show this triangle right here is congruent to this triangle right here, then I can get some corresponding parts out of it. So let's go ahead and do that. What I'm going to do is take a look at distance PS. So I'm going to try to find the distance of PS, and that requires a distance formula. I'm going to subtract this and this. So this is negative 3, take away 0 squared, plus, and then I'm going to subtract these two. 0, take away 4 squared, and that's going to end up being 9 plus 16, square root of 9 plus 16, that's square root of 25, so that's going to be a 5. Now I'm going to do this for SR. I'm going to subtract again, and this is going to be 3 take away 0 squared plus 0 take away 4 squared, and we're going to get a 9 plus 16 again, which is 25. Root 25 is 5. So with these two distances, I'm showing that PS is congruent to SR. And PO, from P to O right here, I can see the distance is 1, 2, 3. And I can see the distance from OR is 1, 2, 3. So I've shown these two are equal. And I know SO is equal to itself by reflexive. So the triangles are congruent by SSS. Okay, so now we can say these angles are congruent by corresponding parts of congruent triangles are congruent. And once I show that this and this are congruent to each other, then it must mean that ray SO bisects that angle. All right, we have an angle bisector now in the given. So we're being told that this angle is congruent to this angle by the definition of angle bisector. We're being told that. We know that this is congruent to itself by reflexive. So if I can just show another pair of sides are congruent, I'd be in business. So this is what I'd like to do. I'd like to show that this side is congruent to this side. Remember, this is the point 3, 5. That's 0, 0, and this is 6, 0. So I'm going to work on distance OG, and that's going to be the square root of 3 take away 0 squared plus 5 take away 0 squared, and that's going to be root 9 plus 25, which is equal to root 34. Now I'm going to figure out GH, and I'm going to do the distance formula again. 6 take away 3 squared plus 0 take away 5 squared, which is going to be 9 plus 25 again, which is root 34. This tells me that OG is equal to GH. So I know this is congruent to this. So these triangles, GJO and GJH, are congruent by side, angle, side. I have a pair of sides, a pair of angles, and a pair of sides. All right, this particular problem is a little bit more difficult because there's no numbers here. There's just letters. These letters stand for a number. It could stand for the letter 5 or 4. And the thing is that this letter it stands for the same number. Whatever this is also. So we're going to do the same things we would do with points, but we're going to do them with letters. And the first, it says for us to find the length of the hypotenuse. Now this is the hypotenuse. So we want to find distance PQ. So I'm going to use the distance formula, and I'm going to take my two x's, 0 take away k, quantity squared. Then I'm going to take k, take away 0, quantity squared. And so this is going to be k squared, and this is going to be k squared. So this length will be root 2k squared. And we can simplify that and just say, we know this k squared can come out, so k times root 2. Now, if you want to leave it this way, that's okay with me, but this is a simplified version. Okay, now they want us to find the midpoint, which requires that we use a midpoint formula. So we're going to take the midpoint of PQ, which means just follow the rules. You're just going to work with letters instead. 0 plus k over 2. I'm taking the two x's, adding them together and divided by 2. Now I'm going to take the two y's and divide by 2. And we can simplify this, and this is k halves, k halves. So even though I didn't have numbers, I can follow through and find these lengths that I have. All right, again, we don't have any numbers, we have letters, but we can still proceed. We want to prove these triangles are congruent, and I can see already I have a reflexive, so that's good. Now I'm going to try to figure out the distance OT, which requires that I use the distance formula. M take away 0 squared will be m squared. K take away 0 will be k squared plus k squared. Now I'm going to so I figured out this distance right here. Now I'm going to figure out this distance right here. So this is going to be the square root, and then I'm going to take this, and then I'm going to subtract this. So m plus h, take away h, quantity squared, plus k, take away 0, quantity squared. Now we know that these h's are going to cancel, and we're going to have m squared plus k squared. And you can see that this and this have the same distance, so I'm going to put a little tick mark there. Now I'm going to try to figure out what TU is. Now TU is horizontal, and we know that they have the same K, so I'm not going to use the distance formula. I can see that I'm going from here to here, so this must be H. So this distance is H, and I don't have to use a distance formula. Now to find this distance right here, remember, has the same level, and H right here, it's telling me I'm going over H units. So this is H. So this tells me these are congruent. And once I do that, I can see the triangles are congruent by S, S, S. I've shown all three sides are congruent. Okay, last one, coordinate proof. We want to show that these triangles are congruent. I can already see I have a reflexive side right here. And I would like to look at OP. Now OP is vertical, has the same Y, so it looks like I'm going up this amount, 2H. And then I want to figure out this length, and the Y's are the same, so how much does it take for me to go over? And that's going to be 2H. So I can see I have a pair of sides here. Okay, now I want to figure out what PN is, and I'm going to use the distance formula. So I'm going to do 0 take away h quantity squared plus 2h take away h quantity squared. This is going to be h squared, and then 2h minus h is h, and then you square it, that's h squared. If you want to simplify it, it would look like this, 2h squared. So this length right here is, we found it here. Now we're going to find this length right here. And so I'm going to do the same thing. I'm going to subtract these two. So 2h take away h quantity squared plus 0 take away h quantity squared. And when I simplify that, that's going to be h squared plus h squared. So, and when I simplify it, it'll be 2h squared. So I have found that these lengths are the same representation. So I'm going to put 2 tick marks here. So these triangles are congruent by S, S, S.